All right, buckle up, everybody, because today we're talking about seeing planets around other stars.
Not just, knowing they're there.
Yeah.
Actually seeing them.
Like getting pictures.
Pictures, exactly.
Well,
We're talking about NASA's Roman Space Telescope. And a key piece of tech that's going to make this happen, the Roman Coronagraph Instrument.
It's pretty revolutionary stuff.
It is, and it's complex. So today we're deep diving into how this thing works, why it's a big deal, and what it means for finding other worlds out there.
And I can tell you, finding exoplanets, that's a challenge and a half.
Oh, I bet. Why is that?
Well, think about it. You've got these tiny planets.
Tiny.
And incredibly faint, right next to these blazing stars.
Ah, so it's like...
It's like trying to spot a firefly next to a spotlight.
Okay, yeah, that's a good analogy.
That's what we're dealing with. And the coronagraph, that's designed to overcome that challenge.
So before we get into the nitty-gritty of the coronagraph, let's give our listeners a quick rundown of the Roman Space Telescope itself.
Sure. Roman, it's set to launch no later than May 2027. Okay, so we've got a few years.
A few years, yeah. But it's going to be worth the wait. Roman's going to have a field of view 100 times larger than Hubble.
Wow.
Meaning it can see a much larger chunk of the sky.
Okay, so it's seeing more, but what's it actually looking for?
Well, Roman has a few big goals.
Yeah.
It's going to tackle dark energy, map out exoplanets, and explore the universe in infrared light.
A busy telescope.
Very busy. And the coronagraph, that's just one of the instruments it'll be carrying.
Right, so let's get back to this cosmic blindfold. How does the coronagraph actually block out starlight?
It's actually pretty ingenious.
I'm intrigued.
So basically, it uses a system of masks and mirrors. These aren't just any mirrors, though. They're deformable,
like those funhouse mirrors.
Exactly.
Right.
But tiny and super precise.
So they can adjust.
Yes, they can adjust to block out the direct light from a star.
So it's creating an artificial eclipse inside the instrument.
Exactly. And by blocking the starlight, it reveals the much fainter light reflected by any planets orbiting that star.
Okay, that's pretty clever, I have to admit. But this sounds incredibly complex. What's the scale of this thing?
Well, the coronagraph itself, it's about the size of a baby grand piano.
Wow, that's a lot bigger than I imagined.
It needs to be that big and incredibly precise to manipulate light on such a fine scale.
So it's not just building the thing, it's also getting it onto the telescope. That must be tricky.
It definitely takes some finesse.
Oh.
There's a specialized adapter to make sure it fits perfectly onto Roman's instrument carrier.
Okay.
And then they use this tool called the horizontal integration tool to gently maneuver the coronagraph into place.
So it's not just like...
Not like plugging in a USB.
No, definitely not. And I imagine temperature is a big deal, right?
Absolutely. Even tiny temperature variations can distort those delicate optics. So the coronagraph is carefully insulated.
To keep it stable.
Exactly. Because even a slight misalignment could throw off the entire operation once it's in space.
So it's a very delicate process.
It is. But when you consider what we might learn, it's worth every bit of effort.
I think that's a great place to leave it for this part of the deep dive. Join us next time when we'll explore those potential discoveries in more detail.
I can't wait. See you then.
See you next time. All right, so we've got this piano-sized instrument blocking out starlight, revealing hidden planets.
But it's more than just taking pretty pictures.
Right, we're
gathering information.
Okay, so how do we actually go from seeing these planets to understanding what they're like? What are we looking for?
Well, the light that we gather from those planets, it's like a messenger.
A messenger?
Yeah, carrying information about what those planets are made of.
So we can actually figure out the composition of these distant worlds.
We can. It all comes down to the way that different elements and molecules interact with light.
Okay, now you're going to have to break that down for me.
Sure. Think of it like this. Every element, every molecule, it absorbs and reflects light in a unique way.
So it's like a
fingerprint, a signature.
A light fingerprint.
Exactly. And we can analyze that light, split it into its component colors using a technique called spectroscopy.
And by looking at those colors...
we can identify what those atmospheres are made of.
Oh, I see. So if we see the fingerprint of, say, oxygen, that's a good sign, right?
Well, it's a piece of the puzzle.
Because
oxygen's one of those things we associate with life as we know it.
Right.
But it's not the whole story.
So what else are we looking for?
We're looking for a combination of factors. Things like temperature, size, the presence of other gases.
Yeah.
Methane, for example.
Methane.
Yeah, another potential biosignature, a hint that there might be biological processes happening.
So it's not just about finding one specific thing. It's about looking at the big picture.
Exactly. We're looking for clues, patterns, things that point towards the possibility of life.
That's pretty amazing. So we could actually answer the question of whether we're alone in the universe.
Well, that's the hope.
And even if we don't find life, we're still learning a lot, right?
Oh, absolutely. The Roman Coronagraph, it's going to help us understand how planetary systems evolve.
How so?
By studying planets at different stages of development, we can see how they change over time.
So
Like a cosmic time machine, in a way.
we can look back in time and see how these planets formed and evolved.
We might see gas giants forming, rocky planets cooling.
Even planetary collisions.
Potentially, yeah. It's about understanding not just individual planets, but the entire dance of planetary systems.
So it's giving us a broader perspective on how planets and solar systems work.
It is, and that includes our own solar system.
Oh, so we can learn about our own cosmic neighborhood by studying these distant worlds.
Absolutely. By comparing and contrasting, we can gain a new appreciation for our own place in the universe.
It's like holding up a mirror
Yeah, seeing ourselves in a new light.
and realizing that we're part of something much bigger.
Exactly.
You know, it's easy to get caught up in the science, but there's also a human element to all this, isn't there?
Oh, absolutely. This mission, it represents centuries of human curiosity.
It's this drive to explore.
It's about pushing the boundaries of knowledge and understanding our place in the cosmos.
And it's not just about the big names, the scientists and engineers.
It's about the countless individuals, the technicians, the support staff, everyone who's contributing to making this mission a reality.
This global collaboration, it's really inspiring.
It is. It shows what we can achieve when we work together towards a common goal.
And in this case, that goal is potentially revolutionary, to uncover the mysteries of distant worlds, to find out if we're truly alone.
It's a mission that can redefine our understanding of ourselves and the universe we inhabit.
And that's something worth celebrating. Now, let's dive a bit deeper into this collaboration. Who's doing what, and how does it all come together?
Sure, so NASA's taking the lead on this one, with Goddard Space Flight Center managing the overall mission.
Okay.
JPL is responsible for developing and building the coronagraph instrument itself.
And we've got the European Space Agency, ESA, involved too, right?
Yes, they are. They're providing the spacecraft bus, which is essentially the foundation of the telescope.
The chassis.
Exactly. And then we have JAXA, the Japan Aerospace Exploration Agency.
What are they contributing?
They're bringing their expertise to the wide field instrument, Roman's main camera, if you will.
So we've got the US, Europe, Japan all working together on this.
And that's not all. We also have contributions from CNES, the French Space Agency, and the Max Planck Institute for Astronomy in Germany.
Wow, so it truly is a global effort.
It is. It's a testament to the power of international collaboration in science.
It's amazing to think about all these brilliant minds from around the world coming together.
To push the boundaries of human knowledge.
And to potentially rewrite our understanding of the universe.
Exactly. So we've talked about the technology, the science, the collaboration, but let's take a step back for a moment.
Okay.
And really appreciate the scale of what we're talking about here.
It is pretty mind-blowing.
The Roman Coronagraph, it's a symbol of human ingenuity, our curiosity, our desire to explore.
It's a reminder that we're capable of achieving incredible things when we set our minds to it.
And while there are challenges ahead, and there's no guarantee of success.
Space exploration is always a risk.
It is. But the potential rewards, the discoveries that await us, they make it all worthwhile.
And even if we don't find exactly what we're looking for, the journey itself will be transformative.
Absolutely. We'll learn so much along the way, paving the way for future missions, inspiring new technologies.
So as we eagerly await the launch of Roman,
and the groundbreaking discoveries it promises.
let's take a moment to appreciate the journey that has brought us to this point.
A journey driven by human curiosity and a thirst for knowledge.
And as we look ahead to the future of exoplanet exploration, one question looms large.
What will it mean for humanity if we do find evidence of life beyond Earth?
That's a question that could fundamentally change our understanding of ourselves and our place in the universe.
It's a question that we'll explore in more detail next time.
So, join us then as we delve into the profound implications of discovering that we're not alone in the cosmos. All right, so we've talked about how the Roman coronagraph works and why it's such a big deal.
Yeah, this incredible tech that could help us find life on other planets.
But let's take a minute to really think about what happens if we actually find proof that we're not alone.
Oh, that's the big question, isn't it?
Yeah.
It's something people have wondered about forever.
It really is.
And now we're actually getting close to maybe having an answer.
It's kind of mind-blowing.
It really is.
Yeah.
And the implications are huge. It's not just about science. It affects how we think about everything.
I can imagine. So let's say the Roman Coronagraph sends back data and it's super clear.
Showing signs of life on another planet.
Yeah. What happens next? Do we make a big announcement? Do we call up the aliens?
Well, not so fast. First, there'd be a lot of double-checking, triple-checking.
Makes sense.
Scientists would go over everything with a fine-tooth comb. Other teams would try to get the same results.
So it's not like we just take it at face value.
No. This would be the biggest scientific discovery ever.
Yeah, you can't mess that up.
Exactly. But once it was confirmed, well, it would be huge.
I bet. Like worldwide news.
Oh, yeah, bigger than anything we've ever seen.
Hmm.
It would change everything about how we see ourselves, our place in the universe.
I can see that. Do you think it would lead to even more space exploration?
Definitely. Funding would go through the roof. We'd be building even better telescopes, launching new missions.
Maybe even figuring out how to travel to other stars.
That's not impossible.
Yeah.
There'd also be some fear, probably.
Yeah, I was just thinking that. It's a bit scary to think about what else is out there.
The unknown is always a little frightening.
For sure. And we wouldn't know anything about these aliens, would we? What they're like, if they're friendly.
Right. It would challenge a lot of our beliefs, make us ask them really tough questions.
So it wouldn't just be a scientific discovery. It would be a huge cultural shift, too.
Yeah, exactly. It would be a turning point for humanity.
Wow, that's heavy stuff. But it's also exciting, right? The Roman Coronagraph could help us unlock this whole new chapter in human history.
It really could. It's a reminder that there's so much out there that we don't know.
And that the universe is full of possibilities.
It is. The Roman Coronagraph might be the key to some incredible discoveries.
Well, I think we've given our listeners a lot to ponder today. This deep dive has been amazing.
It really has. Talking about the possibility of finding alien life, it's not something you get to do every day.
For anyone who wants to learn more, we've got links to resources in the show notes.
And if you have any questions, you can always reach out to us on social media.
We love hearing from our listeners.
We do.
Because that's what it's all about, right? Curiosity, exploration, always wanting to learn more.
That's the spirit.
And maybe, just maybe, thanks to the Roman Coronagraph and all the people working on it, we'll finally have an answer to that big question. Are we alone?
It's a possibility.
Until then, keep looking up, keep exploring, and never stop asking questions.
That's the key.
That's a wrap for this deep dive. Thanks for listening, and until next time, stay curious.